This week we're starting back in on our electrical work at the panel. But wait, let's take a minute and step back. Last year around this time we were pushing hard to finish framing and to get the zip system sheathing on our roof, get it taped, and to keep out the weather. And we didn't quite make it. This year we've got the house fully sealed up from the elements and just a few more projects to go on the outside, so we're going to ease back into the interior rough trades. And it's been months since we've done much there. Since spring, in fact.
To run some of the home runs and just getting the basics of where all the wiring is going to go box to box figured out now that I have the layout for all the boxes done.
As the weather turned and we got to head out and get some work done on the farm, then finally start our siding, and it took the summer and fall to get that done. Let's take a minute to figure out where we left off on the electrical work, since that's what we're going to start and try and finish up on first.
So obviously a lot of ways you can do it. I'm going to start just working on the ones that are closest to the panel here. And that's going to be the dining and island is going to start from that plug. This is the first laundry room plug. There's the one that's going to actually feed the washing machine, and then there's one over here just right at the entrance. The things to keep in mind with your laundry room plugs, not your dryer plug, that's separate, but your laundry room plugs, obviously they have to all be GFCI. However, they have to be on their own circuit as well, separate from everything else, but they can all, if you have more than one, they can all be on the same circuit. So your washing machine and any other plugs in the room can be on one circuit. Once we step out of the laundry room, dining room, and specifically the island here, which obviously you can't come from above or from the sides, it's an island. You have to come from below. Outside of those, I'm not going to be taking any wires that I don't have to through the floor. So it's probable that the only other one, other than the laundry, that I'm going to take through the floor is going to be the range. Just wiring up the end of a three-way switch for the stairs lighting. We're doing 3 lights, one over the landing, one kind of interim, and then one down below. And I'm hoping that this cord, this wire, will reach from the first, or from the light that we're going to put kind of right up in there, down to the far end. It's going to be real close. I waste time when I try and find the right use for the last scrap of a roll of wire. So that's pretty much how much wire we've got to work with, and I think we've made it. So to make sure that I have enough wire coming into these, usually I'll just run the cord over to the adjacent joist and then just bend it. And then that way I have enough to get anywhere I need to within that void. Now, in this particular case, I am going to want to go ahead and pull this in and staple it. So I'm going to give myself an extra couple of inches and then bend that. And that's going to sit somewhere like right in there. Now, I don't usually staple all the way in until I know that I'm done in that spot, because you can run 2 wires through one of these staples. They have sufficient capacity. So typically, like, obviously power's got to get here from the switch, which is down by the window. So there's no reason for me to staple that all the way. And I can pull that tight down there and get it right where I want it. Staple that in and then jump him over the box. Now it's every 4.5 feet that these need supported, and this is an 8-foot wall, so in theory I only need one more kind of up in here someplace, but I usually split it and just go ahead and do more than is required by one, just because I like what it does with the wire. Kind of controls it in a way. So let's talk about smoke alarms, carbon monoxide detectors. So we're here on the first floor, and our house does not have any bedrooms per se on the first floor. So there's only a couple of spots where they need to go. Now the code says that you need one that's going to be outside of any sleeping areas. Again, no bedrooms, so that kind of solves that. However, the office could be considered a bedroom if it had a closet in it. And so we're going to go ahead and have at least two on this floor. One outside of that space in the hallway that also leads to the stairs, which you need to have one in either the living area, the living room, if you have such a thing, which most people do, or in that hallway leading to the stairs that go up to the second floor. So this is where that's going to be for us, right up here. And you can see that is really centrally located in this hall, kind of right over the bench for seating, leading up the stairway. And there's your hallway down to your kitchen and living areas. And here's the office. We're also putting one up here in the office, just a smoke alarm. Carbon monoxide needs to be one on every floor, so this one's going to be a dual purpose. Out here, it does say in the code that you can also, you don't have to, but you can, and we decided to do so, put one out in your living areas. So there's one right there, and that's the first one in the sequence. We have a fireplace, needs to stay away from the fireplace. We have a kitchen. All of the cooking stuff is on that side, and this is like washing and sink. So again, stay away from your range and everything else in there, or it will create a nuisance trip. This is kind of nicely located to be near the dining, but away from it, near the kitchen, away from it, and at the very edge of the living room, away from the fireplace. So I'm pulling the home run for the smoke alarm set right now. And one thing you'll want to know about that is that you can do it in 12 or you can do it in 14, and either is fine, but it does need to be on its own circuit minus maybe a light or two. And in fact, sometimes that's recommended, so you have an additional indicator for when that circuit is tripped. And this will serve not only as the power cord for this light, which will run back to these, basically like a little mini hallway through here. It'll be very commonly used because as you come in this door, this will be the first switch you can reach to turn on this interior light. There's also an exterior fan light here, but this is the first one and it should be very commonly used. So that will power that light set, and then from there it's going to go up and power that smoke alarm as well. It'll give us a lot of advanced warning if we were to have some kind of an issue with that circuit being tripped for some reason. Being on otherwise its own circuit means we shouldn't have much of any issues with it. One thing to keep in mind too is that if you want these to be able to be interconnected without having to be wireless, so they can be connected wirelessly, but if you want them to be able to be hardwired interconnected, you're going to need to bring 14.3 or 12.3 out of the smoke alarm boxes after the first one. And then you just use the red wire to interconnect all of the smoke alarms to where if one of them goes off, then they all will go off at the same time. 14.2 or 12.2 is fine coming in and bringing power to the box, but 14.3 or 12.3 going out.
There you go. Good job. You did it.
It didn't seem like it at the time, but looking back at the long summer, it seems so short now. Simultaneously, it's like I can't figure out how finishing the shell of the house took that whole time, and like I'm not sure how we managed to fit it all in. Now the leaves are all coming off the trees, the cold, and more than I'd like, the wet and the dark of autumn is here. Plants are going dormant except for their roots, and we're jumping back in with both feet to refamiliarize what we'd already done, starting at this panel. I'm very appreciative of past me for labeling every wire on both ends so I can mostly tell what I was doing at a glance. This is only my third panel, and only my second full building running wire, so it's far from muscle memory for me. It can be intimidating seeing the amazing work that others share online with neatly bundled wire and immaculate organization in the panel. And I agree, you can call a perfectly laid out panel like that art. I'm not an artist. I've never had the dexterity for straight lines, and I know my work doesn't meet that standard. I'm okay with that. What I am focused on is completing this work in a workmanlike manner, easy to follow, easy to work with down the road, safe, and compliant with code requirements.
So we're most of the way done on this one side that I'm on here. That puts us about halfway, not quite. We have a couple of things that are missing. We haven't run the wire yet for the effluent pump, and we haven't run the wire for the and we haven't run the wire for the interior blower and heat coils on the HVAC system. And that's partly because I actually picked out the wrong wire. So this is supposed to be a 30 amp circuit. I had it as a 15 before we decided to go ahead and do the coils because it didn't need more than just a basic 15 amp circuit if all it is going to be a big fan. But we are going to add some heating coils. And I'm not going to go to any extremes with it. I'm not that worried about it, just enough to kind of temper the cool air that happens when your unit's going to go into the defrost cycle. So if you don't have some kind of heating coils in there, the fellow who we did a trade for part of the cost of the trailer that we sold, we actually sold to an HVAC guy. And he said that if you don't have that, then the defrost cycle will blow cold air because it won't stop blowing. So that makes sense. So we're going to go ahead and run number 10 for this. It's just a 10-2. And then on the other side, we have a 35 max ampacity circuit breakered off of a 40. And the wire therefore needs to be an 8. So that's also just an 8-2, nothing more extreme than that. That one is going to have to head all the way across the building and then pop down and out of the building. So we'll have to junction box and then transfer it out into either conduit as a different type, or I suppose you could do direct burial. Probably we're just going to push it out in conduit and then run it over. You can see we've got, quite a few on this side that are already done though, and that feels really good. So we ended up, this was where the air handler was going to be here. And so we ended up with an extra. I don't know what we'll do with that yet, but it would be a shame to waste the breaker. Those things are so incredibly expensive, those arc fault, especially if they're an arc fault GFCI combo. That one is a combination AFCI. So yeah, it's sufficiently expensive. I'd like to use it. And now that we have all of this done, it should be a fairly quick amount of work to get that side done. And then we've got some that are coming up here as well from various areas, laundry on this side. One of the kitchens is on that side, specifically the island. Now that the panel is pretty much done, other than the things that we haven't wired yet, we haven't run the wires for, we're going to go ahead and fill in those last few wires that we have, which will leave like one or two that are different sizes than I'd originally been planning on. I need to, purchase them, get them out here, and then we'll get those installed as well. And so right now we're running the plugs to the far side porch, and then we're going... What? Why? I'm very intelligent. Yes, very intelligent. All right, let's figure out where this nastiness is going here. You can see the problem, I'm sure. Can't exactly sandwich that to the drywall. That one, I believe, is, yep, there's that.
So that is this guy. So that comes back behind there, comes down. That's kitchen 1. So what that is this one. So the unfortunate part about this particular one is that it is back in there. In order to unclamp that puppy, I did not anticipate. This is in the middle of the kitchen, so there's lots of plugs. And those aren't secured, so I'm just gonna pull it back out through there and then rerun it on this side, because that panel is gonna be really hard for me to get that last back piece fixed. A good reason to really look through things and refamiliarize yourself. I haven't done electrical work in here for probably 5 months now, so that makes sense, I guess, that I maybe was a little hasty on a few things. Stupid. What did we just do, bud?
We made a new wall.
We made a new wall. This looks like a weird thing, and that's because it kind of is. So we were looking at ways to dampen sound between one boy's bedroom and the other where we are now. And research basically turned up that, you know, your main thing is going to be your sub sounds, and they will just vibrate right through that wood. At least that's what they'll do if the wood is continuous. And so we're essentially setting up a second wall in that space with as little extra space taken up as we could manage. So what that meant in this case was simply we added a strip. It's half of a 2x4, and these are all kiln dried so that they would, you know, right away be the right size. And then we're just putting one nail on the bottom into this one. This is not a structural thing at all. You can see up here at the top, I actually have a little piece missing. I gotta add that in at some point, but not a huge deal. It's just hanging drywall is all this is. It's just a drywall hanger. But what it does, hi buddy. What it does is it gives us 1.5 inches of depth between this board and the drywall on this side, and the same thing on the other side. And the wires will all run on that side. So this side will put in the insulation. You know, I suppose we could run insulation on both. But, you know, standard 2x4 wall interior insulation through this cavity. And then just the one, you know, plug had to be moved over from the previous spot it was on that board to here for this wall, because this side, you know, that's part of why I chose this side. That side has 2 plugs. I did leave a little bitty gap in between, and, you know, that may help a little bit. It's just kind of the depth I wanted versus the size of the strip of, you know, one 2x4 cut in half. That's very helpful. All right, so a little project we have right now. So these are not copper, these are aluminum, and they can oxidize over time. So we're going to put a little antioxidant on there. Now the panel manufacturer specifies that with this panel, you don't have to do that. And so this is extra. And they do say if you're going to use an antioxidant compound, which you can, although it's not required with this panel, then you need to use a specific type. And the brand Noalox does not have, and I had looked this up previously, I forget exactly why, but the brand Noalox, it's a different formulation than what I'm using, which is OxGuard. So this is allowed and Noalox is not on this Square D panel. But all I'm going to do is I'm going to take some of this OxGuard. I just kind of made a slit in this and probably should have worked it a little bit bigger to make this go faster. Since it's doesn't have like a seal, it's just you have to cut it. But we're just going to work this onto the threads, and I think they recommend it was emery cloth. Just get this up into there. Yeah, there we go. That's pretty good. And then just tighten her back down again. Okay, that's what I got. I'll check the specifications on that and use the correct tool. Make sure I get that exactly where it's supposed to be, but
Thanks for watching. I hope you have a great day, and we'll see you next time.